Section 8.8, we'll be discussing parametric equations. We're going to start with just a couple of basic definitions. A plane curve is a set of points x, y such that x equals f of t and y equals g of t. And f and g are both defined on an interval I. So you've got two separate functions that are defined in terms of t. The equations x equal f of t and y equal g of t are parametric equations with parameter t. This sounds more complicated than it is. It's actually pretty simple to work through these types of problems. In example 1, we're given that we're asked to let x equal t squared and y equal 2t plus 3 for t in the interval from -3 to +3. Graph the set of ordered pairs x, y. So what we're going to do, since both of our equations are defined in terms of t, we're going to do a t table. We're going to do a column for t. We're going to do a column for x. We're going to do a column for y. Once we have these ordered, the x, y ordered pairs, we're going to graph on our Cartesian coordinate plane. So these calculations are pretty simple. Now, how do we know what to put in for t? Well, that's determined by the interval that we're given for t. So our t is defined in the interval -3 to +3. The brackets, of course, tell us that we include the endpoint. So we could put -3, -2, -1, 0, 1, 2, 3. Okay? If t is -3 in the x function, I'll put -3, I'll square it, I'll get 9. If I put -3 in my y function, 2 times -3 is -6. -6 plus 3 gives me -3. So we have an ordered pair 9, -3 that we can graph. And we just continue and fill out the table like that. I'm going to pause it. I'm going to complete the table. I'm going to let you do the same thing. And then we'll go. My voice is getting hoarse, so I'm going to try to save my voice as much as I possibly can here. So I'm going to pause it. Okay, so I've completed my table. I'm now going to plot these ordered pairs that I've found just by doing simple substitutions. So I've got 9, -3. It's over here. 4, -1. Here's 1, 1, 0, 3, 1, 5, 4, 7, and 9, 9. So we're going to connect our dots. And it's going to go like this. Now, because this one had a specific beginning and a specific ending, these are all the values that we got. So you're not going to be putting arrows on these at the ends. They're just going to stop at those points here and here. Okay, but that's all we were asked to do, so that's what our graph looks like. In example 2, we're asked to find a rectangular equation for the plane curve from example 1. So we've still got the same function that we were working with in example 1. Rectangular equation just simply means you can think of that as y as a function of x. So maybe y equals x squared, y equals square root of x, etc. All right. So to do this, really all we need to do is, since both of these equations are already in terms of t, we can solve one of them for t and then substitute it into the other. So like we could start with a more simple looking one. For example, if you take the x equal t squared, if we were to take the square root of both sides, we would have the square root of x equals t. Just substitute now here into the second equation, so you get y equals 2. T is equal to the square root of x plus 3. This gives us the equation that we're looking for. We also have to say which interval this is in terms of x. So the original was given in terms of t. How do we determine the interval in terms of x? Well, if you go back to where we graphed it, x is defined for these values in our table, and that's it. So you can see it includes 9410149. Now it would also include numbers in between these, but it's not going to go any higher than 9, and it's not going to go any lower than 0. So we would say that this is defined for x in the interval 0, 9. Okay, so those values came directly from our table of values in example 1 where we graphed it. For example 3, we need to graph the curve and find a rectangular equation for the curve. This time we're working with sine and cosine. We've got x equals 2 sine t, y equals 2 times cosine t for t in the interval 0 to 2 pi. So we're going to do a table of values this time as well. So we're going to do a t column, an x column, and a y column. Alright, t is going to go from 0 to 2 pi, so we can put in 0. I'm going to do pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so if I put in 0 for t, my x is going to be 2 times sine of 0. Sine of 0 is 0, so 2 times 0 gives me 0. And if I put 0 in for t into my y function, cosine of 0 is 1, multiply by 2 I get 2. Alright, if I put in pi over 2 for t, sine of pi over 2 is going to be 1, multiply by 2, I get this. And put in pi over 2 for cosine. Cosine pi over 2 is 0, multiply by 2, I get 0. Putting in pi into the x function will give me 0. Putting pi into my y function will give me negative 2. Putting 3 pi over 2 into my x function will give me negative 2. Putting 3 pi over 2 into my y function here will give me 0. And then 2 pi, I'm back at 0 again. That's going to give me 0, 2. Okay, so we've got our ordered pairs. I'm going to list those. It was 0, 2, 2, 0, 0, negative 2, negative 2, 0, 0, 2. Okay, connecting these will give us a circle. I know it's a circle because I know it has to be a curve. Sine and cosine are going to be curve functions, and they make a complete circle for us. So that's what our graph looks like. We're also asked to give a rectangular equation for the curve. So let's see if I got some space on the next page to do that. No, I don't. Sorry about that. We're going to have to, let's come up here. I think we have room. So to get our rectangular equation for this problem, we're not going to do it quite the way we did the previous ones. When we were working with the earlier equations that we had, it made sense to solve one for t substituted into the other problem, but it's not going to work so well to do that here. Okay, but what we can use to help us, we can use the trig identity, sine square theta plus cosine square theta, the Pythagorean identity, equals 1. Alright, so how's that going to help us? Okay, well, if we substitute in, let's take what we've got, x equals 2 sine t, so if I solve that for sine of t, that would be equal to x over 2. So I can substitute, I'll do a little bit more scratch work. I'll squeeze it in on the side. I have x equals 2 sine t If I solve this for sine of t, that gives me x over 2. If I square both sides, I've got x over 2 square equals sine square. So I could, and then of course x over 2 square, that's x squared over 4. Okay, so sine square is equal to x squared over 4. Okay, very similar work is going to show you that cosine square equals y squared over 4. Okay. Now we know that we've already graphed this, we know it's a circle, so we know what to expect as far as our equation. In multiplying both sides of this by 4 will give us x squared plus y squared equals 4. So that's the equation that we're given. Now what are the, what values of x do we need to consider here? Let me see, did they I don't remember if we were specifically asked to give the interval for x, but I think it's assumed. I gotta double check. Yeah, we have to say for what x values that we're getting this. So look at our table, our x values, they go from a minimum of 0 to a maximum of, they go from a minimum of -2 to a maximum of +2. So we need to say this is for x in the interval -2, +2. So that's also part of our answer there. Okay, so this is the graph, and this is the equation that we were asked to provide. And of course it definitely matches up. You can type this into your graphing calculator, you'll get a circle with radius 4. Example 4. We have to graph the curve and find a rectangular equation for the curve. So pretty similar to the earlier ones. We can start with our table. This time we're working from -infinity to +infinity. So I'm going to put in -3, -2, -1, 0, 1, 2. Chances are that's going to be enough information for us. And I'll put in a +3. So if I put in -3 into my x function, well, x and t are equal, so I can fill all this in. The whole x column I can fill in. Okay, y values. If I put -3 in for t, that gives me square root of 9 plus 2, so square root 11. I'm going to put in decimals since I'm going to be graphing this. The decimals will be a little bit more helpful for me in terms of finding it on my graph. So I have the square root of 11. That's approximately 3.3. I don't know if that's showing up very well. I'm going to try to zoom in a little bit. Okay. If I put in -2, I've got the square root of 4 plus 2, so square root of 6. And that gives me an approximate value of 2.4. Putting in a -1 is going to give me square root of 3. And square root of 3 is 1.7. Putting in 0 will give me square root 2, which is about 1.4. Putting in 1 for t gives me square root of 3 again, which is 1.7. And then I get 2.4 and 3.3. So let's see how this looks. Okay, so we're graphing these ordered pairs. And I'm trying to save my voice. So we have enough information now to know what to expect with the rest of our graph. Remember, this one was defined from negative infinity to positive infinity, but we can see the pattern if we just continue to keep going the same way. It's hard to tell if it's a curve. It is a very slight curve. A very slight curve. It looks like almost like a straight line. If you were to graph this on the graphing calculator, it is going to look like it's going to look like the absolute value function on your calculator, like a V shape, but it is still a curve. But this is what our graph looks like. We also need to find the equation for our we need to find our rectangular equation. So this is one where we can just do a simple substitution. So we'll do y equals square root, put in x squared, x in place of t. And this one is for x, for all x. Negative infinity, positive infinity. Let me zoom out a little bit. Let's see, so hopefully that one's pretty straightforward for you. Alright, let's look at example 5. Right here. This time we're asked to graph the cycloid. So remember, cycloids are kind of funny looking shapes. We had some that had kind of like this type of shape to them. Those are the cardioids. All sorts of different shapes that they can turn out to be. With the cycloids, you're not going to be asked to give an equation for these. So it's just going to be a matter of graphing it. That's it. So to graph this, there's different ways you can go about this. Of course, you could still do the table. So you do a t column, an x column, and a y column. But you'll notice this time t goes from 0 to 4 pi. So to get a decent idea of what's going on here, you need to do 0, pi over 2, pi, 3 pi over 2, 2 pi, but you got to keep going, 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So it's a lot of calculations to do. And then you have quite a few calculations. You can certainly do it this way. It just takes a little bit of time. And there is a faster way that you can do it. You can actually go to your calculator and adjust a few settings, of course. But we're gonna use our calculator to graph a parametric equation for us. So to do this, I need to go to you need to go to mode, and you see just under where it says radian degrees, the next row down, you've got this PAR. So you go down row 4, arrow over once, and you're going to hit enter, and that's going to change it to parametric equations. And once you've done that, you can go back to y equals, and now you'll see where you're asked to put in an x and a y equation. And you can do more than one. We're just going to do one set of equations at a time. And for t, you're still going to use the x button like you did before, and it's going to show up as a capital T, so don't let that confuse you. So let's put in the equations that we were given here. We were asked to graph x equals 2t minus 2 sine t. One other thing, you need to make sure your calculator should be in radians. So if you've not check that, go back, check to see that it's in radians. If you do this in degrees, your graph won't be right. So it's got to be in radians. Go back to y equals. So 2t minus 2 sine t. Y equals 2 minus 2 cosine t. And I just messed that up. I've got to do it over. So, excuse me while I type that in again. So 2t minus 2 sine t and 2 minus 2 cosine t. Okay. Next thing I have to do, so I've got it all typed in now. I next have to go to my window. The interval that I'm given for t, I'm going to be putting in for t min and t max. So my t min is going to be 0. My t max is going to be 4 pi, and you can just say 4 second pi. That's all you need to do. T step would be like, and you'll notice when I moved away from it, it converted it back to a decimal. I think it was probably already set to 4 pi anyway. T step is the same thing as like your x scale, your y scale. It's like how far do you go from one unit to the next. Mine is set at 0.25, and that was working fine for me earlier. I don't know if that's the default setting, but 0.25 seemed to be working okay for me. So you can do yours the same if you like. Okay, x min, x max, we don't have that because we haven't calculated it, but I did earlier, and I'm trying to remember what I used. It's the same scale that you would use for any graph, and with these being sine and cosine functions, you know that your sine is going to go from typically from -1 to +1, but we do have some adjustments here. You can see the amplitude is 2, so you might want to put in, let's try 5 and -5. So for the y's, for my y min, I don't know. Let's try 30. Let's go to x min, do -30. X max +30. We'll see what happens from here. Don't worry about x scale. You can just kind of skip over that. Hopefully it's set at a good place for you. I don't really have a recommendation for you as what it should be. Y min is negative. I'm going to do -30, +30 for the y scale. And I'm going to go to graph, and I'm going to see what I have. Okay, so I've got these two little half circles over here, or two little half ellipses. I'm going to zoom in on this a little bit more, so I'm going to go to zoom, and I want to do a zoom box, so 1. I'm going to arrow, I'm going to find my cursor. I can't see it now, I see it, my cursor is right here. So I'm going to go up a little bit more, enter. And then I'm going to hold my arrow key down, and so it'll take it as far to the right as I need it. I'm going to take it all the way as far as I can. And then I'm going to go down so I can get a better picture. Enter. Okay, and that is my graph. That's the cardioid that I'm seeing for when I calculate from 0 to 4 pi. So it looks like these two little half circles here. This problem, for your purposes, will be multiple choice. So once you've got a picture to look at, you can just choose the right one, and there's only going to be one. I mean, you'll obviously be playing with it, but this is enough for you. We can graph this. We can draw it. And we've got this shape. It's the same shape you'll get if you go through and do all of the calculations. So I think that's enough for our purposes though. So that's example 5. Okay, example 6 asks us to graph a Lissajous figure. I never heard of that before, but according to our textbook, these figures occur in electronics and may be used to find the frequency of an unknown voltage. And the textbook gives you a picture of what they typically look like. It just looks like a scribble that happens to have symmetry. To me, that's what it looks like. But for us, we're going to graph this, and we're going to use the calculator to help us again. So we are going to go back to y equals. We're going to type in these two equations. So our x1 will be 2 cosine t. Our y1 will be 3 times sine t. Okay, you'll notice that you have 3 windows here. This time they're actually telling you how to set your window, which is nice. So the first, it says we're going to graph for t in the interval 0 to 6.5. So go to window. T min will be 0. T max will be 6.5. I'm going to keep t-step the same as before. It worked okay for me. The next two windows, the next two intervals that are given, the first one is going to be the x window, and the second one will be the y, max and min. So for x min, we'll do -6. X max, we'll do +6. For y min, we'll do -4, and for y max, we'll do +4. And let's see what we get. There we go. We've got this oval just appeared, or this ellipse. And let's see, I'm just double checking to make sure that's what I was supposed to get, because I forgot. I think it's right though, because I don't know what we could have done that would have missed. Okay, something's not right here. Let me go back and see if I typed that in correctly. I didn't. Sorry about that. We were doing 2 cosine t for x. Y was 3 times sine of 2t. So let's do it again. Now we'll go to graph. This is the graph we're supposed to get. It looks like a butterfly. Okay? So don't worry about having to draw this. You'll just be choosing it from a list of possibilities in my math lab. And but at any rate, it looks like a butterfly. So it comes out looking like this. It's supposed to be symmetric. I've never drawn it before, but that's what it came out looking like. So that's it. So that is section 8.8. I believe my eyes won't focus. Yeah, 8.8. All right. Thank you, and good luck with these. We'll see you in class.